Hello everyone and welcome to Physmania. In the last video we saw how to add vectors geometrically. In this second part we're going to see the mathematical properties of vectors, and in the next part, in part 3, we will be seeing how to add and multiply vectors mathematically. First, let's look at what are the components of a vector. To understand what the components of a vector are, let's pick a coordinate system in rectangular coordinates. A coordinate system is nothing else than a system that allows us to locate the position of an object in space. This is what in mathematics we sometimes call the y and x axis. So given a vector A in our coordinate system here, we can describe this vector as the sum of two other vectors, with one vector being parallel to the x-axis and the other one being parallel to the y-axis. Therefore, mathematically, we can write the vector A as the sum of the vector A in the x-coordinate and the A vector in the y-coordinate. So this means that to describe the vector A, we only need two numbers. In this case, these two pieces of information is what we call the components of a vector. As you can see here, for example, in order to describe this vector, we will only need these two pieces of information, which generally we'll call in A, which refers to the x-coordinate, how much it's moved in the x-coordinate, and B, which it refers to the y-coordinate. But how can we find the components of a vector? Well, we can find the components of a vector if we're given the magnitude and the direction of this vector. So now I want you to imagine that we have this vector A, right, which has some magnitude A and has some direction, or in this case, which is the same thing, the angle with respect to the x-coordinate, theta. Then by basic geometry, we can derive these equations that say that the x component of the vector ax is equal to the magnitude A times the cosine of theta of the angle. Then also we have that the y-coordinate of the vector, the ay, is equal to A times sine of theta. Let's look now at an example. What are the components of vector D if its magnitude is D equals to 4.5 meters and its angle is alpha equals to 37 degrees? Okay, so looking at the image of this problem, we see that vector D is making an angle of 37 degrees with respect to the x-coordinates. So now we have to be a little bit more careful in how we do the problem, because before we derived these equations that you see here, in which we have that dx is equal to d times cosine of the angle and dy is equal to d times sine of the angle. However, these equations were derived with respect to the x-axis. So now we have two ways in which we can do the problem. Either we find the angle with respect to the x-axis, which we're calling here theta, or we find new equations so that we can use the angle with respect to the y-axis. So let's do first the problem with respect to the x-axis. Because the x-axis and the y-axis have a 90-degree angle, we know that theta must be 90 degrees minus alpha, which is 37 degrees, which give us 53 degrees. Then, having this angle, we can use these formulas above, and we have that the x component of the vector is equal to the magnitude of 4.5 meters times cosine of 53 degrees, which give us 2.71 meters. Then the y-coordinate we have from this equation, that is the magnitude equals to 4.5 meters times sine of 53 degrees, which give us 3.59 meters. Then the second way we can do this problem is by using geometry to find new equations. In this case, we know that the vector d and the y coordinates create a right triangle, as we can see here. Therefore, we have a 90-degree angle here, right here, and we can use simple geometry to find our equations. And as we can see, right, the opposite side is the x coordinate and the adjacent side of the triangle is the y coordinate. Therefore, our x coordinate of the vector, right, or x component is equal to d, the magnitude, times sine alpha. And then the y component, which is the adjacent, is equal to the magnitude of the vector times cosine of alpha. Therefore, plugging the numbers, we have that for the x component, we have 4.5 meters times sine of 37 degrees, which is equal to 2.71 meters. And then the y component is equal to 4.5 meters times cosine of 37 degrees. And this gives us 3.59 meters. And as we can see, both forms to find the result agree. Now imagine that we have the values of the components of our vector. Can we find the magnitude and the direction of this vector? Of course. As we can see graphically, a vector forms a right triangle with its component. Therefore, from Pythagoras' theorem, we know that the hypotenuse is a square is equal to the sum of the squares of the sides, as we can see here. So c squared in this right triangle is equal to a squared plus b squared. And then taking this analogy to our vector, which forms also a right triangle, as we can see here, we have that the magnitude a is equal to ax squared plus ay squared, which ax is just the component in the x direction and ay is just the component in the y direction. Therefore, we have that the magnitude of the vector is just the square root of ax squared plus ay squared. Now, to find our angle theta with respect to the x coordinate, we have that theta from basic geometry is equal to the tangent inverse of ay, the y component, divided by ax, the x component. Let's look now at an example of how to find the magnitude and direction of a vector. So we have a vector b that has components bx and by in the xy plane, given by bx equals to -1 meter and by given by 1.3 meters. So what is the magnitude and the direction of this vector b? So the first thing we're gonna do is draw this vector. So we know that by moves 1.3 meters in the y positive direction, and then we know that bx moves -1 meter in the negative x direction. Therefore, as we have seen before, we can now find this vector geometrically, right, by doing this propagation here of both axes, and we can just draw from the origin a line representing the arrow, the vector, at the point where these two propagations meet, and this will be our vector b. Now the next step is to look for this, use the components that we're given and find the magnitude of this vector b. So we're gonna use the equation that we derived before, which says that a is equal to the square root of the x component squared plus the y component squared, but use it for vector b. Therefore, our vector b is going to be the square root of -1 meter squared plus 1.3 meters squared. and all of this to the square root. And this gives us as a result that we have b is equal to 1.6 meters. And now to find our theta, or angle theta, we just use the equation that we also derived before, which is tangent inverse of by divided by bx. This gives us that we have tangent inverse of 1.3 divided by -1 meter. And as a result, as you can see in your calculator, this gives us negative 52 degrees. Now, does this result make sense? Yes, it does. And what is saying this result of having a negative degree is only that our angle is being measured in the opposite direction of our convention. Our convention says that if we move from the x-axis towards the y-axis, meaning in the counterclockwise direction, we're moving in the positive direction. But if we're moving opposite to this, meaning from the x-axis or the negative x-axis towards the y-axis, then we are in the negative direction. So this means that our angle is right here, in which theta is equal to 52 degrees, to those 52 degrees. Sorry. So now we can leave the result like this, or we can find the result in the positive direction. And to find in the positive direction, let's say that this direction here, this angle here is just gamma. And to find gamma, you can simply find it by using simple geometry, which we know the angle between the positive x-axis and the negative x-axis is 180 degrees. So to that, we just have to subtract the 52 degrees that we find above, and this subtraction gives us 128 degrees in the positive direction. So with this, we finish this video for today. I hope you liked it, and I hope you have learned a lot. So thank you very much for watching my videos.